competition universities for Goal 13. As you know, this is the third edition of this contest, and this time we're focusing on solutions for the energy transition. We're organizing this webinar because we thought it would be great, an opportunity for everyone participating to delve deeper into the topic and have a thorough discussion about it. And the webinar will consist of a short presentation from Dr. Maximilian Schnippering, Head of Sustainability at Sustainable Development, and he'll give us a comprehensive overview of the transformations required to achieve a decarbonized energy system. And I'm hoping also that this will be a great opportunity to learn about some of the needs and some of the difficulties that this transformation has, but also get a glimpse of some of the latest innovations in the renewable energy sector, or how this industry can reduce its waste while addressing the remaining barriers to become a stable and decarbonized electricity system for all. After the presentation, we'll have the chance to ask questions and have a brief discussion. This will be moderated by my colleague, Marta García-Haro, who has been leading this project along with Rocío Millán. I want to thank both of them, as well as Siemens Gamesa as a whole, for promoting this initiative with SDSN. We're very grateful for your support, and we look forward to continuing our journey together. Before I close, I want to give a special mention to some of our mentors. I believe that we have some of you present today. The mentors will spend time with the students over the coming months, helping you perfect your project. So thank you for your time, your energy, and I know your enthusiasm. I know that from previous editions. Nothing else from my side. Maximilian, over to you. Once again, thank you so much for joining us.
Thanks, Maria. And hi, everyone. I'm Maximilian. And first challenge of today is that I will start to try sharing my screen here. But it looks like it worked out. So again, yeah, hi from my side. Really delighted to share with you today some more insights on the university challenge and the challenges we see in the energy transition. And while preparing for this event, even though it's a very interesting topic and topic I'm very passionate about also, I became a little devastated, because if you take a look at what's currently going on in our world, it's clearer than ever that closing 2023, we now arrived in the middle of the climate emergency. It's no news to any of us that global average temperatures have been rising now for decades, but in 2023, we saw an unprecedented acceleration of rising temperature levels. In 2023, it's been the warmest year recorded ever, and by far. So our world basically is slowly dying if we continue with business as usual. But it's also no time to give up. There is hope, and you are part of it, because one of the key levers to fight climate change is the decarbonization of our energy systems, because at the end, more than 1/3 of all CO2 emissions globally are somehow related to it. So our planet urgently needs us to get the energy transition in order. If we now take a more careful look at what is needed, then on the one side, if you take us, Siemens Gamesa, we are leaving quite a positive handprint behind by installing new wind turbines. Just to give you an indication, last year we installed around 9.2 gigawatts of new wind capacity around the globe. And by displacing conventional power plants, new turbines avoid more than 24 million tons of CO2 year by year over their whole lifetime. So it's really magnificent how much CO2 emissions you can save by installing new wind turbines. But next to our handprint, we also leave a footprint behind by installing new wind turbines. Because at the end, if we install new wind turbines, this also comes somehow with an impact that we need to manage. So last year, we roughly caused 4.1 million tons of CO2 by our activities along the whole value chain. And even though the gap between the 24 million for the next 20 years and the 4 million for the last year, it doesn't mean that we can now opt for an early retirement and lay back and don't do anything about our impacts. No, as it is true for all industries, we all need to do our bit. And to drive a sustainable energy transition, we also need to think about how can we improve the impacts in the wind industry and for the energy transition. Now, that's also the reason at the end why we have created this university challenge. And I would like to explore a little further with you what we actually can do if we want to drive a successful energy transition. So something that is really important for me also when I talk to policymakers around the world is that we need to think the energy transition holistically from end to end, and we need to think connected in terms of industrialized ecosystems. So when thinking about adding new wind farms, I had a nice discussion with the Australian ministers, for example, also, where you say, we need to think about co-locating also high energy demanding industries. So connecting production and off-taking. We need to think holistically also about transmission of electricity, and we need to think also about storage of it, so that we not only decarbonize our existing energy systems, but that we also think about how can we utilize new forms of energy generation now to also decarbonize further industries related to it. And let's make this very practical. A good example is wind turbines need steel, and steel is an industry that also comes with a significant footprint. So for us, it's really important that we decarbonize the steel industry to use greener steel for our turbines. Decarbonizing the steel industry means we need a lot of electricity and hydrogen, something renewables can produce again. So the energy transition is not only displacing conventional power plants and electricity will now be coming from renewable sources. No, it's also thinking connected in terms of industrial ecosystems. And I brought this picture here with me today because many of you have seen somewhere a wind turbine, know how a wind turbine looks like, but also for thinking holistically, it's important to see there are these main components that drive basically the impact. And it starts all with the wind turbine, which consists of the tower, the nacelle, the blades, and the hub that connects the blades to the nacelle. And then for offshore wind, but also for onshore wind, we see foundations in different shapes and forms to connect the wind turbines with the ground. Then the electricity needs to go somewhere, or the energy, depending if it is electricity or hydrogen, what is produced. And here you can see already that we need the substations alike, and further down the value chain, we also need the transmission systems, and we also need then the storage systems to think again holistically how we can drive the energy transition. Now, to better understand where we are coming from and thinking specifically about the wind industry also, it's always really crucial to take a look at the life cycle. And generally speaking, we see 5 life cycle stages here for our industry. So raw materials are used and transformed into products through various stages of the value chain. These can be the blades, nacelles, the towers, as you just saw, or also the specific pre-products to get to them. Then afterwards, after the products and components have been manufactured, the wind turbines are installed, so that turbines afterwards, for most of their life cycle, 20, 25, sometimes 30 years, can turn and produce electricity or energy. And at the end of the life cycle, the turbines are then dismantled and materials are returned as new raw materials into the life cycle as input for future turbines. And here it's really important for me, if we think about now life cycles, it nicely connects also to think about circularity. And circularity is a topic that is really crucial, because if we think about also the planetary boundaries that we see, so that our planet can only operate within its limits also, we need to consider how we can embrace more circular ecosystems and circular economy also on the micro level for our companies. And what we see here is that when we talk about circularity, we talk about it from different perspectives. So on the one side, we are aiming to design our turbines already as circular as possible, so make them easily recyclable. If you think about wind turbines from a mass perspective, more than 90% of the mass of a wind turbine is steel. The rest is then copper, aluminum, fibers, resins. But as you can see already with the steel, that's a material that is very easily recyclable. However, there are also some other components where it's a little more difficult, which is specifically the blades, because the blades consist of glass fibers, carbon fibers that are mixed with resins. So you end up with very strong mix of materials that is not easy to break up again afterwards. Here, again, thinking in the design phase already about recyclability, we developed the recyclable blade quite lately, 2-3 years ago, which was a very long-lasting project and process to bring it into the market. It all started also with a master thesis some time ago. So other students, similar like where you are now, also started to think about what could be a good solution to solve the problem of making blades more easily recyclable. And this took like almost 8-9 years then to materialize into reality. But it all started with this thesis, and it was successfully implemented so that we could develop now the recyclable blade, which resulted in the change into the resin formula, which allows us now to separate again the fibers and the resins much more easily and bring the materials back into raw material cycles. So step one, really important, thinking in the design phase already, how can we design wind turbines to become more recyclable? Standard wind turbines now are at roughly more than 95-96% recyclability. So comparable to what we also see with in the automotive, aerospace industry or alike. On the other side, it's also about thinking then as the next step, working together with our suppliers in the supply chain and ensuring that our suppliers increase the use of secondary materials. So we want to foster that not only virgin raw materials are utilized in our supply chain, but we want to foster the usage of more secondary raw materials as well. And that's something that is also very important for many reasons. On the one side, this is the circularity thinking in the cycle. However, this is also significantly contributing to lower our carbon footprint or our environmental footprints, because using secondary raw materials will come with much less impact compared to virgin materials, where you need to do all the mining and refining and processing and the like. So therefore, increasing the share of secondary used materials is one of our key priorities also in that regard. Then we also work together with our suppliers to minimize waste along the supply chain. And that's something that is also accounting for us in our own manufacturing and assembly for the nacelles and the like. We also need to carefully manage our waste and ensure that no waste goes to landfill, that there is no hazardous waste involved. The amounts of waste that occur as part of our manufacturing, they are comparably low, but still it's very important for us that no waste goes to landfill, but all comes back into the cycle. And then when the turbines are running from a circularity perspective, it's really important that you perform a dedicated maintenance and service operation. It's really important for ensuring that we repair as much as possible, replace components, that we bring them back into the life cycle, and that we extend the life cycle as much as possible. So that then at the end of the life, we can prepare for the decommissioning and have a recycling strategy in place, how we can treat the different materials and bring them back into the life cycle. So thinking theoretically about circularity, you might have all heard about, I don't know, is it now 9, 10, 12 R's, reuse, recycle, repurpose, and so on. And so basically what you really do in practice is that you cover all of these areas. And it's important to cover them along the life cycle stages. Now, this leads to the question for us, at the end, how can we, along this life cycle and these different steps that I was just sharing, reduce or improve our ESG impact, our environmental and social impacts along the value chain? And this is something that is really important for us, because if we take a look at how to manage now sustainability, then sustainability in the from all companies at the end needs to be covered from an end-to-end perspective along the value chain. So covering supply chain sustainability, sustainable operations, and sustainable products, while then connecting it to sustainable customer relationship management to bring and embrace sustainability along the value chain. And one of the main underlying factors here that we also need to watch out for are the regulatory requirements that are impacting then the financing, the customer decisions, and also how we need to manage our environmental and social impacts. And I wanted to share this slide here with you, because one of the key trends in sustainability is to advance and bring sustainability down to the product and material level. So in the past, it was always very driven on the corporate level and supplier level, where you more say a company needs to have an environmental management system, a company needs to have a decarbonization target, a company needs to comply with XYZ, and so on and so forth. What we see now is that there's a clear trend on bringing this down on the product and material level. And again, the life cycle is really important here, and the life cycle assessment is really important. So what we also did is that we reviewed the turbine along the life cycle, and then if you want to do it, you go actually part by part. So you have a big bill of materials where you can see all the different components, parts, products that are within a wind turbine, and it's around 5,000 different products. And you can review what is the environmental impact of all of these products based on the materials that they consist of. And one of the key parameters, of course, for us is CO2 emissions, because CO2 is really something that that can help us to guide our decisions at the end. And something we identified here along the life cycle stages is that, as you remember, 90% by the mass of the turbine comes from steel. But if you compare it now to the CO2 footprint, we identified that 36% of the CO2 footprint is related to the tower, 28% to the blades, 36% to the nacelle from a component view. From a material view, we can see that still 62% are related to steel, but we also see high impacts from aluminum, epoxy, the resins, polyurethane, the rare earth materials, copper as well. So there are a lot of different materials that actually drive more impact behind that needs to be transparent. And to build this transparency, again, life cycle and life cycle assessments are really important for us to build that. And it's really important for us, if we think now about the energy transition, that we start thinking about the materials behind. So that's something I wanted to take a closer look together with you now, because raw materials are basically the key ingredients for driving a successful energy transition. And we performed here an analysis that is focused on the EU energy transition, but it holds true for other areas around the globe. So we calculated basically what it would take if we would build all the wind turbines needed for the EU energy transition until 2050. So the EU has laid out clear targets where they want to go, where we currently are, so how many gigawatts need to be installed, and we calculated back what are the materials that we use. So if we take a look at this here, then we can see that actually we only would need 6% of 1 year's global steel production volume to build all the wind turbines needed for the next 26 years in the EU. We would need only 1% of the global aluminum production volume throughout the whole world to build all the wind turbines needed for the EU energy transition for the next 26 years. I could go on now, raw material by raw material, but you are smart, you can read yourself the percentages here. So it is showing, yes, wind turbines do need raw materials, but wind turbines only need raw materials at the beginning of their life cycle. And wind turbines only need a limited amount of raw materials to decarbonize our energy systems. But here's the but. It also makes it difficult for us to act on these raw material markets and to work on improving the footprints on these markets. So on an aggregated level here, you can see basically 3 different markets that we are working on. The classical traditional markets for steel, copper, aluminum, which have been significantly out of balance over the past 2-3 years. They are more than saturated, and for our industry, it has become very difficult to act competitively on these markets, to secure also the volumes that are needed. We sometimes see also some protected markets, like for rare earths or balsa wood, where limited diversified supply chains are available. And we need to think about what to do, because at the end, some events could happen that significantly disrupt our supply chains. Think about floodings, wildfires, so climate-related disasters that are more likely to come in future years. That will make it very difficult to mine or source from specific areas sometimes. And lastly, we also see growth markets like for carbon fibers, glass fibers, or green steel, where we see materials that are not only important for our industry, but for many more. And strong policy making here is needed to ensure investments also in the build out of these technologies and innovation to make these technologies more cost competitive in the market. And for these materials and supply chains, we again need to think about how can we connect and embrace circularity? How can we lower environmental footprints during the processing, during the production? How can we ensure the availability of skilled labor? Because jobs like in responsible mining, in processing, in manufacturing, these will be at the core of driving a sustainable energy transition. So summing up this a little now and bringing it back into perspective, to drive a successful and sustainable energy transition, we need to think the energy transition in holistically in industrialized ecosystems, so that we can ensure to connect the generation, the transmission, and also the storage along the whole value chain. We need to improve the sustainability on the product and material level across all the different materials used, so that we can minimize also our environmental and social footprints. And we need to consider the related socio-economical aspects to drive also the progress in the communities where we are part of. Keeping these guiding principles in mind, fighting climate change is one of the biggest challenges for our time. But together we have the solutions to fight back. So that's why I'm also very happy we have this university challenge together with you to find more solutions to support the improvement and enable the successful energy transition. Many thanks.
Thank you, Maria. Are you there? Okay.
Yes, thank you very thank you very much, Maximilian. And I'll give the floor now to Marta, who is Senior Manager at SDSN and can manage the Q&A session. Marta, over to you.
Thank you very much, Maximilian. It's been really interesting. I think you've given us a really great overview of the challenges, and specifically here today we have invited all the universities that are participating in the Universities for the Goal 13 competition. So I think you have provided many ideas for their potential solutions. But of course, there may be many questions around what you presented or other challenges of the energy transition, not specifically related to wind energy. So I open the floor for anyone who would like to ask Dr. Schnippering, about if you have questions about his presentation, about any other aspects, he will be very happy to answer to you. You may raise your just raise your hand or write in the chat. You can also turn on your video and just ask for a question. I can also see some of our focal points at the universities have also joined this webinar. So, of course, Roger or Yi, Tao, some of the university staff could also intervene if you wish. Oh, Roger, hello there. Would you like to ask something?
Yes, Marta, I'll get the ball rolling while the students are coming up with their own questions. Thank you very much, Maximilian, for your presentation. If I understood correctly, when you were talking about 6% of global steel, that was just for European wind, and you're not including solar and wind in other countries, plus concrete for hydropower and lithium for batteries around the world. Do you have a sense of, if you add up everything you need for every country around the world, what does that do to the percentage of the raw materials compared to what we currently produce?
Thanks for the question, Roger. And next time I will join you. Looks very nice outside.
That's true. We're just in the middle of our summer. It's very pleasant.
Yeah, I know. No, and yeah, we not to date we have not conducted yet an analysis for the whole globe that we can see overall what will be the demand. But what you can estimate is that if you see the big energy users around, or regions around the world, that it's quite comparable what we then would see: Europe, China, Australia, Africa, North and South America. So it's quite comparable what we would see. Still, and the main outcome is what we see also, we need 6% of 1 year steel for all wind turbines to build turbines for almost 30 years here. So that's really, really low amount. Now, if we would add up all the other things, yeah, the percentage would increase, but still it would not be much higher than 1 year's demand to decarbonize our electricity system then for the next decades to come. So that's something very, very important as a finding for us. We didn't conduct an assessment also what it would mean for other forms of electricity generation, but wind and solar will be the main forms of generation. But when we see also the build-out targets from the latest COP, there's also some nuclear power and the like, some hydropower, but these projects are really, really minor compared to the build-out targets in gigawatts, what we see for the other forms of electricity. So I would say it would still remain a fairly low amount of raw materials needed that could afterwards help to decarbonize everything.
Thanks very much for that answer. I can
Fantastic.
ask another question, Marta, if
Yes,
no one else
please.
is.
Unless somebody else wants to come in, yeah, Roger, go ahead.
Okay, so raw materials are a really important part of the problem, but refined products and human resources are probably going to be the bigger constraints in the system. What does Siemens think about in terms of human resources, having enough engineers, project managers, lawyers who understand renewable energy laws and for getting projects connected to the grid, etc. How are we going to get around those resource constraints?
Very good, yeah. Yeah, and here I think it's again helpful to think along the life cycle. So as you rightfully say, yeah, we need for responsible mining, processing and the like. We need also human resources, skilled labor that can do the job. We need also manufacturing capacity for making the big castings, making the blades, making bearings, making complex products. We need also a lot of installation capacity, So we need vessels, people that, service technicians that go on a vessel, go somewhere on an offshore site, install turbines and the like. Then we will need also people for the continuous service that needs to be provided for these wind farms that are sometimes in very difficult areas to reach. And absolutely, we also need around a lot of professions that help with what does it mean from business administration perspective, from a legal perspective, also from weather forecasting perspective, for example, geology perspective. So thinking about the energy transition, it's really a blend of multiple professions that are needed to drive a successful energy transition. And yes, we already see, like in Europe, for example, we see now already a shortage of skilled labor. We also see in many areas in the world a shortage of skilled labor when it comes to people that are very detailed in knowing how to make steel that can help come with the right properties that are needed for specific purposes sometimes. So really specialized knowledge is also missing, because you will need a lot of that for all these big steel components also, so that there will be no structural damages when the turbines are turning for 30 years outside. So yes, that's a big topic where we say for the energy transition, we need to think about good mechanisms, how to promote that young students, like also here in the forum, can see there's a spot for me in so many different ways. So it's not only I study sustainability and then I do it. No, it's almost no matter what you study, there's something where you will be needed also to support the energy transition. And that's a connect we need to make, and where we need to also show that this is on all the life cycle stages, from mining to processing to installing, and then the framework around.
Thank you very much. Johan has raised his hand. Go ahead, Johan.
Yes, thank you so much, Marta. And thank you so much for your presentation, Maximilian. And I just have a very quick and simple question, what are the current trends in sustainability right now in general, and also in the wind industry in particular? And do you have anything specific that you would like emerging from the solutions that we present?
Very good, yeah. One of the key aspects in sustainability, as I wanted to showcase also a little with my presentation, is that sustainability has emerged from something to comply with into something that goes down the whole value chain on the product level and material level to really drive impacts in terms of decarbonizing products, ensuring products live up to high human rights standards, ensuring there are no environmental violations along the process, like wastewater or a lot of waste or biodiversity or like. So bringing this down to the product level is really something where we would say that's one of the key drivers currently. And we can see in our industry, to provide now also the regulatory framework for this, that this is complementing by ensuring that non-price criteria are increasingly introduced into tender requirements. So ultimately, it means if there's a big auction for an offshore wind farm and our customers participate in these auctions, then it's not only who is the cheapest one who can build the wind turbines and produce the energy for the lowest cost. It's also about thinking who, from a total value perspective, can bring the most value to build this wind farm. So it's also about who has the lowest CO2 footprint, who ensures that there are minimal standards when it comes to environmental topics reflected, who has the highest share also of skilled labor in the local areas to promote also development in the communities where you are part of, who is also ensuring that we not only source from big suppliers, but also from small local suppliers in the areas. So there are a lot of consideration to bring sustainability more into the decision making, which makes it now really interesting, because it enables somehow competition also on sustainability, which is, I think, urgently needed to drive not only the decarbonization of the energy systems, our handprint, but also bring down our footprint on the product level.
Thank you very much, Maximilian. So this is really an open discussion. This is the opportunity. We have the pleasure of having the head of sustainability of Siemens Gamesa. He may be able to, yes, like Johan was asking, orient the students on, you know, what kind of solutions they could present. Besides general questions, you could also ask if you already have something in mind, if this, ask us if that would be feasible, anything you'd like to ask. We open the floor. Otherwise, we still have 10 minutes. Oh, okay, Rocio. You go ahead.
Thank you, Marta. No, I wanted to take advantage that we're here with students. Thank you very much for being here, by the way, and thank you, Maximilian, for this great presentation. No, I wanted to ask you, what will be? It's your second edition with a University for SDG 13. Last year was your first one, and you were really in the weeds about it. I'd like to know which kind of advice would you give to the students while they're preparing the project and how to start working on it, because you were talking about an holistic view. So I'd like to know which kind of the tips for the students.
Very good, yeah. And this relates to my previous point. So I think when you think about a potential project, don't think too holistic, like my presentation, but really think about the product level and the raw material level and how to connect supply and demand and thinking in industrialized ecosystems. So thinking about the different components, what they are consisting of, how can we embrace sustainability in that one? And if you go that detailed down the road, I could think about different projects on the site level, where you say, okay, how can we embrace sustainability for new wind farms that we want to build somewhere in terms of biodiversity, acceptance in local communities, also involving local communities in buying and building them. On the product level, then how can we also work on the logistics to have a good footprint to bring products somewhere, and because it's big machines and big parts that we cannot ship around the world everywhere. So how can we, from a connected perspective, think how to bring it to the local communities? And then on the product level, thinking about how can we support decarbonization of different components, maybe. So specifically thinking about steel parts, thinking about copper, thinking about aluminum. Are there topics where we say, we maybe can substitute some things? Maybe you lately saw also a company working on a wooden tower, so made out of some wood. But actually it comes with a worse carbon footprint than the steel tower. So again, we need to consider what is actually really the better solution, thinking in the life cycle of these products and how to treat them at the end of the life and the like. So going down the product level is, I think, really important. And next to that, the second lever is then the raw material level. And when I think about the raw material level and responsible mining, it's also how to, from an environmental perspective, improve raw material mining. So if you think about copper mines, for example, these are often some of the most dirtiest places in the whole world. So how to improve water management, waste management, decarbonization of these activities. And also, next to that, how can I drive transparency and due diligence? So how can I trace back from where these raw materials that are maybe mined somewhere in the world end up in the turbine at the end? Because if you think about ourselves, it's very difficult to build transparency. So we're talking about blockchain solutions also that can help to drive transparency, to showcase one material came from here, came to there, came to XYZ. So that there are very new technologies emerging that are helping. So you can see I have a hard time saying in very simple and short words what would be my advice. But my advice to come to that now would be try to be very precise and focus on specific issues, not on how can I save the world, how can I save the environment. Think about how can I focus on a product with a big impact and how can I improve this product to drive impact to then save the world and improve the environment.
Thank you.
Thank you very much. And of course, the solutions can be technical, but they can also address policy changes, citizens' behavior. So really the solutions, you can think on that in many ways. I also invite all the participants to check out the videos of last year's finalists, because they are very inspiring as well. So you can get an idea of how broad these solutions can be. Roger, I saw you turn on your camera, so maybe you would like to ask something.
I just wanted to see if Maximilian could expand a little bit on the types of projects that the students might be looking at. We've kind of talked a lot about engineering solutions on the electricity generation side of things, but what about on the energy use side of things? So efficient use of energy, electric vehicles, smart appliances at the domestic level. You know, there's lots of ways that we use energy that can be done more efficiently, smarter, to help tie in the energy use side of the problem with the energy generation side of things. Is that something that Siemens Gamesa is also interested in the competition?
Mm-hmm. Also, very good point. Yeah, and here again, I would recommend not to go too far away, but I would say we need to think for the energy transition in these industrialized ecosystems. So where to use supply and demand, how to co-locate supply and demand. And like one of the study I conducted also with a master student some time ago is, for example, how many wind turbines, offshore wind turbines, would be needed to decarbonize the German steel industry? And I think that's also a good research question for other countries or regions or areas. So in Germany, there's currently something like 40 million tons of steel produced per year, and you would need 3,500 offshore wind turbines of our newest and biggest turbines to just produce the hydrogen that is needed for the iron ore reduction process. And this is something extremely important also for policymakers to understand. Coming to one of your points, can we actually use hydrogen for fueling cars? Probably not, because we need all the hydrogen for decarbonizing industries like steel, for example, and these heavy processes. And this connection, I think, what can we use renewable energy for? How much do we actually need also for some of the use cases that we see, is also something very relevant for the industrial ecosystem perspective, end-to-end energy transition thinking. Yes.
Thank you very much, Maximilian. I think unless anyone else has a final question, I think we could wrap up here. You answered many of our questions. I hope the students come out from this meeting having at least a more clear idea on the challenges, and now they have to start working and thinking where they're going to put their efforts. Thank you very much for your time today. I will see you this afternoon in the second session of the webinar with the other part of the world. Thank you also, Rocío, for helping us organize this, and I'll see you this afternoon. Thank you, everyone. Thank you, Roger and Yi, for being here as well. Goodbye, everyone.
Thanks a lot. Bye-bye.
Bye. Thank you.